but ultimately it gets in the way of understanding these things deeply. It becomes a pop kind of thing to say. And so I make, in my new book, and in others, I make a real distinction between these two. I don't mean to knock zero-point energy. It's going to turn out to be important in many ways. But people have a real misconception. They think that that's everything, but it's not.
So then there's the vacuum energy.
Right, which is huge.
What you did an analogy last night about the. Could you go?
Okay.
Because that's so much.
Right.
One thing. Let me just tell you, we're going to do this rabbit hole version of the movie, and as we do the rabbit hole version, we talk about a concept. We're just going to basically go down to smaller and smaller, more detailed, and let people burrow in.
Yep.
And of course, the vacuum field is such a wonderful way of just describing that plunge into another reality. So
it is. Well, certainly in my modeling, as you go from normal physical reality, and if you're going to shrink, you're going to go then to the next level, which will be the physical vacuum level of reality. And if you keep shrinking more, you'll go to the emotion domain level of reality. And you shrink more, you'll go to the mind domain level of reality. And you shrink more, you'll go to the spirit domain level of reality. So they're all in this metaphorical picture you're describing of the rabbit hole. And so the one thing that could be said for we'll come back now to the atom molecule level, where we have quantum mechanics on the one hand, and we have relativity theory on the other hand. And for those two to be internally self-consistent, and a sidebar is that science doesn't give you truth. All it can determine is internal self-consistency. Okay, that's all science can do. And for quantum mechanics and relativity theory to be internally self-consistent, the two of them, then the vacuum, the physical vacuum, is predicted to have a latent energy of 10 to the 94 grams per cubic centimeter. Now, in practical terms, how do we grapple with that? All right, we can take a comparison of two things. We can take the volume of the known universe, that is like a sphere with a 15 billion light year radius, and we can multiply it by the average mass density, which astronomers can give us a number for. And so we have the right-hand number. On the other hand, we can take just a single hydrogen atom, which is mostly empty space, and say, okay, let's look at that amount of vacuum, and we'll multiply it by this 10 to the 94 grams per cubic centimeter, and we get a number. And that number is 1 trillion times this number. Now, the assumption in making this sum, the calculation, is you have to assume, or we assume, that the universe is fairly flat, okay? The curvature is very, very small. And that's what astronomers tell us is the case. But it's not perfectly correct. So this isn't an absolutely accurate comparison, but it's a good comparison because it realizes that just that little bit of vacuum outweighs all the mass and all the planets and all the stars, and each of those grams of energy are equals mc squared. So when you begin to really grasp this, you begin to grasp the enormity of the energy that would be involved in going down this rabbit hole. What is available for us to use in the future, to take us to the stars, etc. The issue is we are perturbing this with consciousness. We are able to, with directed consciousness and intention, we are changing things at the vacuum level, which then allow us to access a new level of physics. So we can do that at that level, not so much at the atom molecule level. That's a secondary effect. So we're already doing it, in essence. We're already getting into the rabbit hole by using intention. As you go down, you're going to successively higher gauge symmetry states. And as you do, the thermodynamic free energy per unit volume goes up and up and up and up until you get to the place of what caused the original Big Bang.
So it seems like if there's that much energy in that small a space everywhere, is it almost like we're sitting on top of a huge wave, or it's more like there seems, why doesn't the whole universe just explode then?
Well, it's potential energy. Okay, it's not, it, it has to be unlocked. It's there, okay? It's just as if you have an atom, okay? The fundamental particles are in a combined state, and what their interaction and combining into a stable mode, an emergent property, it is a potential well. I mean, the atom resides at the bottom of a potential well, otherwise it would explode apart. Well, it's the same sort of thing as you go down here. And if you take it as a metaphor that there is a kind of substance, that is, you can think, if you like, you can think of a cosmic atom, and the simplest part is what we know about the electrical aspect of that atom. The next part would be the interaction with the magnetic monopole aspect. And then the next part would be the aspects that relate to the emotion domain, and then the mind domain. And so you build a more and more complex interacting thing, which is doing a divine dance. And so the stored energy is in this unit. All right? So, I mean, in essence, that's what you have to unlock if you want to release and use that energy.
Well, if you have your vibometer, and that can measure conditioned space,
Yes.
is the next step to build a device that actually directly modifies that conditioned space? In other words, first they had thermometers, and then people figured if you light a fire, you raise the temperature, which of course the thermometer.
Right.
So, in your plans, do you see the equivalent of something where a device is built that you can change your symmetry states?
The first level for us is to build a standalone kind of device. At the moment, we have to take three streams of data, and we have to work with the computer to convert them to the theoretical construct we've developed for this particular potential, which is called the magneto-electrochemical potential energy. And it's just an expansion of conventional thermodynamics. And having that standalone, it'll be like a voltmeter in essence. Then anyone could just, plug it into the wall or whatever, and it would register and continuously register what's going on in the room. And that will be the first step. And the second step will be our work seems to suggest that you can enhance the capabilities of every bit of technology that we have in the world today by having that technology run in a conditioned space. Okay, because now you're accessing another level of physics. And that can augment. I mean, the intentions, just as we can change pH up or down by 1 full pH unit, and in living system, you go plus or minus a half a pH unit in either direction, you're dead on both